Kagamath, nananuta pa, may kenina. Maligaral tang ulit, bang mabiyasa. Allow me to guide you in learning different concepts and skills in Mathematics 9. I am Teacher Andrew, your soulmate. Today's lesson is a continuation of what was discussed in the previous episode. Recall that the vertex form of quadratic functions is given by y equals a times the square of the binomial x minus h plus k. Now when a is equal to 1, h is equal to 0, and k is also equal to 0, the function is described by the equation y is equals x squared. This is what we consider as the parent function. Its graph is this parabola. This time, we're going to fix the value of the variable h or of the x-coordinate of the vertex at 0 and the value of the variable k or of the y-coordinate of the vertex varies. Hence, the function is of the form y is equal to ax squared plus k. Let us change the value of k in the parent function and see the effect on its graph. Also, let us assume that a is equal to 1 for simplicity. When k is equal to 1, the equation becomes y is equal to x squared plus 1. The following ordered pairs can be plotted to sketch the graph. 0, 1, negative 2, 5, negative 1, 2, 1, 2, and 2, 5. And you might have observed that this curve is the same curve representing the parent function, but it is just shifted 1 unit upward. Also, you may have noticed that the vertex of the parabola with equation y equals x squared plus 1 is now 0, 1. When k is equal to 2, the equation will be written as y equals x squared plus 2. Notice that no matter what real number we substitute into x, x squared is always greater than or equal to 0. Hence, the smallest value of x squared plus 2 is the square of 0 plus 2, or simply 2. This means that the lowest point on the graph will have coordinates 0, 2. This is the vertex of the parabola. To sketch the graph more accurately, we need 4 more ordered pairs, and this may be given as follows: negative 2, 6, negative 1, 3, 1, 3, and 2, 6. And you might have observed or concluded that the curve is the exact curve corresponding to the parent function, but it's just shifted 2 units upward. The vertex is also changed to 0, 2. When k is equal to negative 1, the equation becomes y equals x squared minus 1. And since whatever real number we put in place of x, the value of x squared is always greater than or equal to 0, the lowest value of the function is given by the square of 0 minus 1, which is equal to negative 1. Hence, the lowest point of the parabola, representing the function y equals x squared minus 1, is given by the coordinates 0, negative 1. This is the vertex. 4 of the other points included on the graph are the following: negative 2, 3, negative 1, 0, 1, 0, and 2, 3. We may say that the graph is the same graph of the parent function, but it's just shifted 1 unit downward. And the vertex is changed from 0, 0 to 0, negative 1. When k is equal to negative 2, the equation will be y equals x squared minus 2. Since squaring x would result to a number greater than or equal to 0, we can conclude that the lowest value of y is obtained when x is equal to 0. And it must be equal to 0 squared minus 2, or simply negative 2. This means that the lowest point on the curve corresponding to the function is given by the ordered pair 0, -2. This is in fact the vertex. Also included on the parabola are the following points: -2, 2, -1, -1, 1, -1, and 2, 2. We conclude that the parabola is the same parabola representing the parent function, but it's just shifted 2 units downward, and the vertex becomes 0, -2. Let's also look at the effects of changing the value of k in quadratic functions whose parabolas open downward. We use y equals -x squared as the reference function, and its graph looks like this. So, when k is equal to 3, the equation becomes y equals -x squared plus 3. Since the negative of the square of x would result to a number less than or equal to 0, we can conclude that the greatest value of y is obtained when x is 0, and it must be equal to the negative of 0 squared plus 3, or simply positive 3. This means that the highest point on the curve corresponding to the function is given by the ordered pair 0, 3. This is in fact the vertex. Now, aside from 0, 3, these are 4 of the points that are also on the curve: -2, -1, -1, 2, 1, 2, and 2, -1. We conclude that the parabola is the same parabola representing the reference function y equals -x squared, but it is just shifted 3 units upward. The vertex is now 0, 3. When k is equal to -2, the equation becomes y equals negative of x squared minus 2. Again, the negative of x squared will always result to a number less than or equal to 0 no matter what real number is substituted into x. Hence, the greatest value of the function is given by the negative of 0 squared minus 2, or simply -2. This implies that the highest point on the parabola is the point 0, -2, which is the vertex. The following points may also be plotted to sketch the parabola: -2, -6, -1, -3, 1, -3, and 2, -6. We may say that this graph is the same graph of the reference function, but it's just shifted 2 units downward. And the point described by the ordered pair 0, -2 is now the vertex. In general, when the value of k in the function y equals a times the square of the binomial x minus h plus k is changed to a positive number m, then the graph of the function is shifted m units upward. When the value of k is changed to a negative number n, the graph of the function is shifted n units downward. This time, both the values of h and k vary. Hence, the equation of the function will be described by the vertex form itself. Y is equal to a times the binomial x minus h quantity squared plus k, where hk describes the vertex, while x equals h describes the axis of symmetry. We will still use the parent function y equals x squared as our reference. We will change the values of h and k in the function and see the effect on its graph. If h is equal to 4 and k is equal to 3, the equation describing the function is y equals the square of the binomial x minus 4 plus 3. Aside from the vertex 4, 3, we may include the following points to sketch the graph. We have 2, 7, 3, 4, 5, 4, and 6, 7. This curve is the same curve that represents the parent function, but is just shifted 4 units to the right and 3 units upward. Now, when h is equal to -3 and k is equal to -2, the equation describing the function can be written as y equals the square of the binomial x plus 3 minus 2. And aside from the vertex -3, -2, the following points are also on the graph: -5, 2, -4, -1, -2, -1, and -1, 2. This parabola is the same parabola representing the parent function but is shifted 3 units to the left and 2 units downward. We also see the effects of changing the values of h and k on the graph of functions that open downward. Let's use the function y equals the negative of x squared as our reference. When h is equal to 4 and k is equal to 3, the equation becomes y equals the negative of the square of the binomial x minus 4 plus 3. Aside from the vertex 4, 3, the following points are also on the curve: 2, -1, 3, 2, 5, 2, and 6, -1. This curve is the same curve that represents the reference function y equals the negative of x squared, but it's just shifted 4 units to the right and 3 units upward. When h is equal to -3 and k is equal to -2, the equation is now expressed as y equals the negative of the square of the binomial x plus 3 minus 2. Aside from the vertex -3, -2, the following points can also be plotted to sketch the graph of the function: -5, -6, -4, -3, -2, -3, and -1, -6. This graph is the same graph of the reference function, but it's just shifted 3 units to the left and 2 units downward. In general, when the value of h in the function y equals a times the binomial x minus h quantity squared plus k is changed to m, the parabola is shifted m units to the right if m is positive, but is shifted m units to the left if m is negative. Moreover, when the value of k in the same function is changed to n, the parabola is shifted n units upward if n is positive, but is shifted n units downward if n is negative.
Ready your paper and pen. It's Math the Moment. You have 30 seconds to answer each of the following questions. If the graph of the function y equals x squared minus 7 is shifted 5 units upward, what will be the vertex of the parabola? The value of k in the function is -7. Shifting the graph of the function 5 units upward means adding the value of k by 5. -7 plus 5 is equal to -2. The equation then will be written as y equals x squared minus 2. Thus, the vertex of the parabola is the ordered pair with coordinates 0, -2. If the graph of the function y equals -x squared plus 5 is shifted 4 units downward, what will be the vertex of the parabola? The value of k in the function is 5. Shifting the graph of the function 4 units downward means subtracting the value of k by 4. 5 minus 4 equals 1. The equation then will be written as y equals negative x squared plus 1. Thus, the vertex of the parabola is the ordered pair with coordinates 0, 1. If the graph of the function y equals the square of the binomial x plus 3 minus 1 is shifted 6 units to the right and 2 units upward, what will be the vertex of the parabola? The value of h in the function is negative 3. Shifting the graph of the function 6 units to the right means adding the value of h by 6. Negative 3 plus 6 equals 3. The value of k in the function is negative 1. Shifting the graph of the function 2 units upward means adding the value of k by 2. Negative 1 plus 2 equals 1. The equation then will be written as y equals the square of the binomial x minus 3 plus 1. Thus, the vertex of the parabola is the ordered pair with coordinates 3, 1. If the graph of the function y equals the negative of the square of the binomial x minus 1 plus 5 is shifted 3 units to the left and 7 units downward, what will be the vertex of the parabola? The value of h in the function is 1. Shifting the graph of the function 3 units to the left means subtracting the value of h by 3. 1 minus 3 equals negative 2. The value of k in the function is 5. Shifting the graph of the function 7 units downward means subtracting the value of k by 7. 5 minus 7 equals negative 2. The equation then will be written as y equals the negative of the square of the binomial x plus 2 minus 2. Thus, the vertex of the parabola is the ordered pair with coordinates negative 2, negative 2.
And that's it, Kagaya Math! Thank you for tuning in. I hope today's episode has been very helpful. Let me end on this note, where what and who you are now is a result of what or who changed you. Be transformed and be better. This has been your soulmate, Teacher Andrew. See you in the next episode. Bye!